And you can see that the field of view is working and also the animation of the crosshair. What makes aiming in a shooter feel powerful? It is not just the animation, it is the camera. In this video, we are going to zoom in and out by changing the field of view of our camera using C++ code to create that proper aiming effect inside our third-person shooter. This is the Game Creator Accelerator channel and I am Tony Munoz. Like, subscribe, comment, share, and ring the bell so you don't miss the continuation of this series where we are building our third-person shooter, Mad Gameverse, step by step, and every line of code is here on this channel for you. And remember, breaking into the gaming industry requires more than just coding. You need a clear plan. For that, take my free training at woolen.com/free training, where I walk you through the core strategies that every successful independent game developer has followed and continues to follow today. And now, let's implement a proper aiming system. Let's get started. First, let me present where we left. Now we have all the animations moving in different directions. And also we set the crosshair, you can see it here, that when I click on right button, you can see the animation of the crosshair. This is pretty cool, but we need an effect of zooming when we are trying to zoom to the crosshair. This is what we'll do today. First, we're going to our project and open the shooter character. In the header of the shooter character, let's add some new properties. Let's go to the end of the private section. And after the play fire montage, let's add the first property, which will be a float, named aim FOV. And the value by default will be 60. FOV will be an acronym for the field of view. Now let's set this property as an Unreal property. Let's pick this default and make some changes. First, I just want it visible, at least for the moment, anywhere. I don't want to change it, but I want to be able to look at it. Look what is the setting. Blueprint read only, the category camera set, and allowed private access. We're going to set it to true. And of course the corresponding comment to set what it is this. Default field of view when aiming. In fact, before this one, I'm going to create another one, which will be the default value when we are not aiming. So float, camera, default field of value, let's say the 90. I think I like that one. And the property will be the same. So I'm going to copy and paste it here. And the comment, default field of view when not aiming. Perfect. Let's go to the next one. Now we need an interpolation speed that will define how fast we'll move from one view to the next one. From field of view when not aiming to field of view when aiming and backwards. For this, also a float, and we can call it field of view interpolation speed. 20 I think is a good number. Then the U property will be the same. And here we can say interspeed for field of view change. Fantastic. And finally, we need to keep the information of what is the current field of view. This will be a float, current FOV, and we're going to set it. I'm not going to set it yet. Let's check the comment. Current field of view used for smooth transition between default. Perfect. Oh, this is the perfect comment. Another thing I want to change is I have a method here, which is the tick method. And currently I place it on public. That shouldn't be in public. That should be on protected. So I'm going to cut it from here and move it to the protected section. And usually because they are part of the Unreal, not properties or method that you are creating, you place it at the beginning of the declaration of the protected variables or methods. And now it's safe. Now let's move to the implementation. First, let's confirm that we have the camera component included, as we did in previous videos. And remember that a little bit on the bottom, when we set the default values, we also create this element, which is the player camera, which is a U camera component that we added to our player's blueprint. This component is essential for what we are going to do next. First, let's move to begin play. After what we already did, let's add if player camera, which, yeah, for this moment is the case, we're going to set our current FOV, sorry, as the camera default FOV. And then we're going to say the player camera set field of view current FOV. This will define the value of the player camera as soon as this character starts. And this makes me think or rethink this section where we defined these values as visible anywhere, not values that we can change. And thinking that we can create different types of characters that have different types of size, it will be nice that we can set these values not here, but in the blueprint. So I'm going to change them to Edit, Anywhere, and Blueprint Read Write. Let me copy this one, I'll put it here, and save. Let's go back to the implementation, and with this we finish the begin play as well. Looking in the methods, we have in the setup player input that we added two events related to when we aim and when we release the aiming. And in these methods, what we did was just setting the value of B is aiming to true or to false when it is released. And all this was set on previous videos. You can watch the link in the description. This B is aiming is key when we are working with the animation of the crosshair. But now we want also to change the field of view. And for that, we'll get into our tick method inside the implementation file. And this will be pretty straightforward. First, we're going to check if we have the player camera. And in case we don't have the player camera, just return. Do not continue with the rest. Now we're going to create a constant of type float named target FOV, which will check the value of B is aiming. If it is true, the value that we assign will be aim FOV. And if it is false, we're going to assign the value of camera default FOV. That will be the target FOV, the target field of view we're moving to. Then we're going to set the current FOV, and we'll use this interpolation formula. Interpolation works in terms of time, and this is why we're using it inside the tick, where we pass the delta time. The first parameter is the current value of the FOV. The second is the target, what will be of aim FOV or camera default FOV. Then we have the delta time, which makes the transition frame rate independent. And finally, we have the interpolation speed, which controls how fast we approach the target of the field of view. The higher the speed, the faster the zoom. The lower the speed, the smoother and slower the transition. And finally, we apply that interpolated value to the camera, which will be this simple line of code. Player camera, set field of view, the current field of view that we just calculated. Save. Let me take a moment. I did not create this channel just to teach Unreal. I created it because I know how frustrating it is to want a future in the gaming industry and not know how to build a real path toward it. I spent years trying to figure it out on my own. Learning tools is important. We do that here. We build real systems, real AI, real gameplay. But coding alone is not a strategy. What changes everything is direction, a clear path, a methodology you can follow consistently even after office hours. This is how I build my path. And it is the same structured approach that independent developers are using today to grow, build publicly, gain visibility, and move toward real opportunities. If you're serious about doing this the right way, I invite you to take my free training at woolon.com/free training. In that training, I break down the core strategies you need to follow to build a successful path in the gaming industry step by step with clarity. Find the link on the top right corner of this video or in the description. Your future in game development does not start someday. It starts the moment you decided to build it. Now let's continue building. Back in Unreal, let's compile. And here we have an error that says blueprint read write should not be used on private members. Okay, let's fix that. So all these values of default field view and until the field of view interpolation speed, Control X to move them from here. And in case I'm going to place them on the protected section. Perfect. So after the aim released, place them here, save, back to Unreal, and let's compile. Perfect. Now we can go to our player's character. Let me check it here. Main character, Wraith. It is the shooter base character BP. Open the full blueprint. And let's look for the section called Camera Set. Here you can see the values of the camera default FOV, the aim FOV, and the interpolation speed. And if you're going to create future characters, this will allow you to set it for that particular character. Ain't that awesome? Back to our map. Let's play it. So here's our character. It is shooting. And now let's try to zoom. Fantastic. But look that the crosshair is not working. Let me try and escape. And you can see this group of errors. This is very important because it is not an error that I have in my project. And I will prove it in a second. The only thing I gotta do is to recreate the project and this issue will be fixed. Let's close this. I'm going to save everything about my project and close it. And the same will be for the Visual Studio. Now in the folder of my project, I'm going to remove VS, binaries, intermediate, saved, and the Visual Studio solution. Now click on my project, right click, show more options, generate Visual Studio project. Once it's finished, open the project here directly. And when this Windows prompt, say yes, we want to rebuild them all. And then you just have to wait a little bit until your entire project is rebuilt. Once the project is loaded, compile, confirm that everything is okay, and now we can test it, and you can see that the field of view is working and also the animation of the crosshair. Fantastic. Now, I'm not saying that this error will be presented to you, but in case that it happens, now you know a simple solution for it. Today we implemented a proper aiming system by changing the field of view of our camera using C++. We did not snap the camera instantly. We built a smooth transition using interpolation inside the take method. We separated input from visuals. We changed the boolean when aiming started and let the system handle the rest. There is clean architecture. That is how great systems are built. Like, subscribe, comment, share, and ring the bell so you don't miss the next episode of Mad Gameverse Development. And make sure to watch my next video on how to hack the gaming industry, where we talk about the mindset and positioning strategies that can completely change your trajectory. And until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.